There are at least 3 and probably 4 different ways in which these chemicals are toxic to you. Let me show you the first one. This is the dioxin-like method. And it's called dioxin-like because the mechanism, this whole cellular mechanism, was not described for PCBs. In fact, it was described for the other compounds I explained, dioxins. And then it was discovered later that some of the PCBs act in the same mechanism. And it's because it works in a lock and key sort of way. Dioxins, because they're fat soluble, or PCBs, will move right into the cell, and they to this lock and key mechanism which goes into the nucleus, and it binds into the DNA and alters the way your DNA functions. Therein lies the problem. Therein lies the way in which it can cause cancer and all sorts of developmental problems. Now, in fact, this figure was stolen from somebody who's really well known in the scientific community locally, Linda Birnbaum here, who used to be a researcher at EPA's Research Triangle Park, but she's no longer there. She's left. I'm happy to say that she is now the director of the National Toxicology Program right next door over at the National Institute for Environmental Health Sciences, which is great news for all of us, because she's a great friend of cleaning up and really understanding toxic chemicals. If we look at this in an easier to view format, this little cartoon, we can look inside the cell and we can say, well, there's this receptor molecule that is the lock, and any one of these compounds can act as the key. It's just that their ability to turn it varies, their potency. That is, some of them are very effective at turning that lock, others not so much, and only slightly able to are the weakest ones. Fortunately, the PCBs are the weakest ones. Unfortunately, they're also present in the largest amounts, which counteracts that. Next. Other PCBs act like estrogen. And if this looks a little similar to the dioxin-like mechanism, it's because it is. It's because a lot of hormones, your steroid hormones, estrogen, androgen, things like that, they operate through the same lock and key mechanism. So you all have estrogen receptors. All of you. Everybody has an estrogen receptors, right? Men and women. Same thing is true with testosterone receptors. There's a balance, and you know which way the balance goes. Estrogen receptors are also common throughout the animal kingdom. All birds and snakes and wildlife and clams and worms, shrimp, lobster, they have estrogen receptors. I think they found them in sea snails and sea hares as well. It's an interesting evolutionary question. But it goes on to explain how it is that PCBs can affect all sorts of animals, because they attack a basic mechanism in biology. Now, don't read this. It's only up here to make a simple point. I told you that the lock and key mechanism has some chemicals that are better keys and more effective than others. Well, these are all the compounds. This comes from the World Health Organization, that radical environmental group. A little bof expertise. The World Health Organization, and Linda Birnbaum sat on that. I'm going to give her kudos because she just recently got that position. All of the compounds here have been demonstrated to have the ability to interact with that toxic mechanism that I described for the dioxin-like compounds, and they can all be rated by their effectiveness of explained it. So we can come up with a ratio. This one is 100%. This one is just as effective as dioxin. This one is only 1/100th, 1/1000th, 1/10,000th. And every few years, the World Health Organization gathers together similar groups of scientists to evaluate those. This is a slightly older table. This table is the newer one. And what's happened in the last few years, fortunately and unfortunately, and you can't see that from the back, is that all of these PCB numbers here, almost all of them have changed. So this PCB has gone from 1 to 3 1,000ths. And this one has gone from 1 to 3. And so many of them have changed. Some of them have gone down, some of them have gone up. But it means that a large number of PCBs are now recognized as being able to have the same toxic effects as dioxin.
That was updated in 2005.
This one was updated in 2005. Yes, right there. And they probably won't do another one again till next year. I pulled out some of the differences in humans, fish, and birds. The 4, 5, and 6 is just how many chlorines are attached. So for all of those that have 4 chlorines attached, birds, as you can see, are dramatically more sensitive, much more sensitive to PCBs. However, not so for this. We're about the same as birds, or birds about the same as us. Not so for this one. And then this compound is an interesting one. This is one of the dibenzofurans. And birds are 10 times more sensitive than are we. Okay? So that tells you, that among all the different animals on Earth, some of them are more sensitive, some of them are less. So for that reason, in some cases, we know as much or more about how these compounds affect wildlife. In mink, one of the earliest investigations was a follow-up to why the natural populations of mink in the Great Lakes were collapsing. They had reproductive failure. They were failing to produce kits. So there were no new ones. Oh, don't you love computers? Mind of their own. So they suffered reproductive failure. And in laboratory experiments, which are not easy on mink because you can't really keep them well in a laboratory, they have to keep them outside in a shed, in an open barn type situation. It turns out that, that in controlled conditions, they're much more sensitive to PCBs than are we. And one of the reasons why that's more important for them is because they're piscivorous. They eat fish. They're an aquatic mammal. Mink and otter and fishers. We don't have fisher down here. They have them in New England. And some other animals in that same family. They survive on fish. More than 90% of the diet of mink is on fish. Same thing is true with river otters. And they feed a lot. Because they're in the water, they have to have this heavy layer of fat to insulate them. And they have a very specialized coating. They also have a very interesting metabolism. They're skittish animals. They have to be able to generate that heat. So they're sort of like a teenager in that regard. And I've done a little bit of work on an advisory committee. Why are mink such difficult experimental animals? Their adrenal glands are on overdrive all the time. And you'd think they were on sugar all the time. I was shocked to discover this a number of years ago.